Hello, AP Calculus students. This is Mr. McAllen, and we are going to be working on the second day of the flipped classroom. We're talking about 8.2 in our textbook, and this is on finding trapped areas. And I have depicted below 4 scenarios for finding trapped areas. The first one we have when the limits are given. They tell us where to start and finish the integral. The second one, we have to solve for the points of intersection. The third one, we have to figure out what subregions need to be constructed to find the total area. And the fourth one, we might have a change of our top function compared to our bottom function. So in this case, you would see for the first integral, integral A, the top function and bottom function would be two different functions than the top function and bottom in the second region. So let's look at the first problem. The example, we have two functions, the top function and the bottom, and the limits are given. So the integral is very easy to set up. Remember, it's just going to be from negative pi over 3 to pi over 3, our lower limit and our upper limit. And we're going to do top function minus the bottom function. Oops. Now the problem with this integral is the integral is not completely able to be solved analytically. The first part is because we know the antiderivative of secant squared is tangent, but the second part is not. As a result, this problem would probably be given to you using a calculator. So the only thing you want to make sure you do before you try to solve it is you want to make sure that you have distributed the negative and then you put it into the calculator correctly. The other thing is when you try to put secant squared into the calculator, remember that's 1 over cosine squared of t. So what you're going to have to do is put it in the calculator as the following. So notice I have to do cosine of t, the whole quantity squared, because that's what that shorthand stands for. And then on this one, you have to do 4 sine of t and square that quantity. So if you're going to use a graphing calculator, you would want to make sure you put the integral in exactly that way, and the end result from what the calculator would say would give you the answer. So I'm going to put it in the calculator, and I want you to pause the video, and I want you to try to put this integral into your calculators and see if you get the answer I came up with. So I'm pausing the video now, and then when I come back, I'll have the answer. So the big thing to remember too, when you're working on this, is that you have to be in radians because we're integrating trig functions. So if your answer does not match my answer, I would check to make sure that your calculator is in radians. Next problem that we want to work on is one where the limits must be solved for. So in this case, I'm going to just draw a little sketch, and this is why you learned how to do transformational sketching in pre-calculus. The first function is a parabola that's been moved down by 2. The other function is a horizontal line at y equals 2. In order to find the trapped area between these two curves, you need to find out when the two curves intersect. So the first step is, besides writing out the integral, put the top function minus the bottom function. And then you need to find your lower and your upper limit. And this is done through solving when these two curves would intersect. Set the one function equal to the other, and then solve. In this case, you get x squared. Remember to bring everything over to one side. X squared minus 4 is equal to 0. And from this, you know that that's difference of squares. And your 2 points of intersection are at 2 and negative 2. So your lower limit is going to be 2, your upper limit will be 2, and now it's just a matter of anti-differentiating. The antiderivative is going to be 4x I need to use more room, minus x cubed over 3. Use the evaluation bar to check it, or to evaluate it at the upper limit of 2 and the lower limit of -2. And when you do that, you plug into everything the upper limit and subtract from it the lower limit plugged in. We just do the math. We have 8 minus 8/3 minus -8 plus 8/3. And this becomes 16, because we have 8 minus 8 gives you 16, minus 16/3, which will give us, when you do the fractional math, 32 over 3. Let's look at our next problem. In this problem, we have to, actually this problem has a misprint. It's y equals negative x squared plus 2. So the two functions in this case are going to bound an area. So x squared minus 2 is a parabola down by 2, and negative x squared plus 2 is a parabola up by 2. We're going to have an intersection between the top function and the bottom. So let's set up the integral. This is the top function, negative x squared plus 2 minus our bottom function, which is x squared minus 2 dx. We need to solve for our limits. So we set the two equations equal. X squared, we have 2x squared minus 4 is equal to 0. We factor out a 2. We have x squared minus 2 is equal to 0. In this case, we get two solutions. X is equal to plus or minus root 2. So the lower limit is going to be negative root 2. The upper limit is going to be root 2. Simplify the integral. We have 4 minus 2x squared dx. We integrate, which will be 4x minus 2/3 x cubed, evaluated at the upper limit and the lower limit. And remember, we have to plug that in and subtract both quantities. So that's going to turn into 4 times root 2 minus 2/3 of root 2 cubed minus the whole quantity where I plug in negative root 2. I'm going to try to simplify this mess. We get 4 root 2 for that part, minus root 2 cubed is root 2 times root 2 times root 2, which is root 8. So I have 2 root 8 over 3, minus, this is going to become, I've got positive, negative 4 root 2, but that's going to, the negative and the negative are going to make positive 4 root 2. And then the last part is going to become a negative, because I have negative cubed, which is negative. I have a negative quantity, so it's going to make it positive. And this subtraction here is going to make it negative again. So I'm going to have plus 2 root 8 over 3. So what's going to happen is this quantity and this quantity are going to cancel each other out, and we're going to be left with 8 root 2. I'm going to double check that with my calculator, and when I come back, we're going to verify if that is in fact the answer. I double checked my work. I checked the negative signs here, and I did make a mistake. This just goes to show you got to be really, really careful with this. That negative is there. This minus and that minus and that minus, they all make a negative quantity. So I really have 8 root 2 minus 4 root 8 over 3. And that quantity is going to be equivalent to, let's just double check what that value is, 8 root 2. On the AP test, you could just leave it as 8 root 2 minus 4 root 8 over 3. But 8 root 2 minus 4 root of 8 divided by 3. And notice in the graphing window, I did the integral just to double check as far as decimal place, and our answer checks here as well. So you just have to, word to the wise, you just have to double check your work when you're evaluating the upper and the lower limit to make sure you get that correct. The last problem we're going to work on is going to be one where we have two sub-regions, and we have to figure those out. This first function is root x. This other function is y equals x minus 2. We need you to figure out what this total area is, but sometimes it works to make up two separate integrals. The first integral would just be root x as the top function and 0 as the bottom function. And you would just integrate that part from 0 to 2, because this is a second hash mark and that's 2. We're just going to assume that that crosses at 2, which I'm pretty sure it does. So you're going to integrate from 0 to 2. The second region is going to be, the top function is going to be root x again, but we're going to take away the area underneath x minus 2. That integral is going to be in a different domain, so it's going to be from 2 to 4. So we work through the integration. Square root of x is integral. That's x to the 1/2. We integrate that. We get x to the 3/2 times 2/3. We're going to evaluate it from 0 to 2. And the other one, we have x to the 2/3 times 3/2, the first part, minus x squared over 2 from that minus x, plus 2x. And we're going to evaluate that integral from 2 to 4. So plugging in the values, I have 2/3 of 2 to the 3/2 power, plus, now I have to work on the other integral. I'm going to plug in 4. I'm going to do the 3/2 power on that, minus 4 squared over 2, plus 2 times 4, subtracting from that the lower limit evaluation. Oh, I have to plug 2 in. I have 2 to the 2/3. That should be 3/2 power. Holy smokes. That should be 3/2 power. This should be 2/3. You got to be very careful and not be distracted. So sometimes little mistakes like this can happen. So again, I got to change that to 2/3. I just, in my mind, I flipped the fraction when I shouldn't have. So you just have to double check these little things. And this is why practice is key. I'm going to minus. I've got 2 being plugged in, so I've got 2 squared over 2. I've got plus 2 times 2. I'm going to pause the video, and I want you to now finish evaluating this. Okay, so I finished everything. It looks like a big, big mess, but if you look at it carefully, you have the antiderivative of the first function from 2 to 0 being evaluated, and that's this part becoming this part. And then you have the antiderivative of the second region evaluated at 4, which is this part, minus the antiderivative at 2. When you write it all out like this and be very careful, notice certain things cancel out, and we end up having an area of 10/3 or 3.333. I verified this with the calculator as well to make sure that it was in fact the right area. And now we have one more type of integral to do. Sometimes it might be easier, instead of using a dx integral, to switch to a dy integral. Now, I'm going to pause the video and I'm going to clean up the drawing, and then it's going to be a couple more minutes on doing a dy integral. But what I want you to do when I pause the video is I want you to figure out if this is y equals x minus 2, and if this is square root of x equals y. I want you to write these equations as functions of y instead of functions of x, because we're going to do a y integral, a dy integral. Okay, I want you to take a stab at switching those functions over, and then when I come back, we'll see what you have. Okay, so we're back, and the two functions are rewritten in terms of y functions. So what you really want to do is consider an integral that goes from 0 up to 2 on the y-axis. So we're going to write a dy integral, 0 to 2. This is dy, so our functions inside have got to be y functions. Our top function is this top function, and we know it's top because this is the direction of the x-axis. Any function that's closer to the top of the x-axis is a top function, and this is the bottom function, y squared. As you can see, because of this integral, we only have a top function and a bottom. We're going to have y plus 2 as our top function minus y squared. As you can see, this integral is going to be much, much easier than we had before. We have to integrate y plus 2 minus y squared dy. The antiderivative is y squared over 2 plus 2y minus y cubed over 3. We're going to evaluate that from 2 to 0, and when we do that evaluation, you're going to see that we just plug 2 in. We're going to have 2 squared over 2 plus 2 times 2 minus 2 cubed over 3, and the lower limit evaluation is going to be 0 when you plug 0 into each of those functions. 2 squared over 2 is 2, plus 4 minus, this is going to be 8 over 3. So we basically have 6 minus 8 thirds. 6 turned into thirds is 18 thirds, minus 8 thirds gives us the same exact area, 10 thirds, that we had before. So sometimes it pays to change the direction of the integral and go from a dx integral to a dy integral. I hope this video helps, and make sure that you answer the short question that I leave in the form for you.